Welcome to Teddy Talks. In this video, we are going to look at motion of connected particles. Now, case one, we are going to consider two masses, M1 and M2, passed over a smooth pulley using a weightless taut in extensible string. Now we are going to see what happens to those bodies or particles if this is our smooth fixed pulley and this is the string. We are saying it is taut. When we say taut, means it is be straight. So now, if this is our body, M1, and this is body M2, we know that the weight of this body M1G will act downwards, and the weight of that body M2G will also act in that direction. Now, let us put a condition that if M2 is greater than M1, what will happen? It means this body is going to be pulled upwards as this one is moving downwards. And we shall have a tension in the string. This tension should balance the what? Should balance the weight. Otherwise, if the weight exceeds the tension, then if it is at equilibrium, if the weight exceeds tension, this thread would break. Now, since these particles are in motion, why? Simply because this particle is heavier than this one. And if it is this one pulling, it means for M1, this is the direction of motion, and then M2, that will be the direction of motion. Now, let us look at, let us consider motion of each particle. Let us consider acceleration of M1. Now, we know that the net resultant force should be equal to, now if this body is moving upwards, then the net resultant force should be tension minus M1G. Why? Simply because for this body to be in position to move upwards, the tension in the string must be greater than the weight of the body. If the weight of the body is less than the tension in the string, then this body or this thing would flow downwards. But we know that from Newton's second law, that the net resultant force is equal to MA. So this implies that MA is equal to T minus, this is MA1 is equal to T minus MG1. So if we make tension the subject of the formula, we see that tension will be equal to M1, G1. We can call this our first equation. Now let us consider M2. Consider M2, what called M2. Now, if we are considering M2, we see that this body M2 is pulling or is making this string to move downward. So the net resultant force, here will be equal to the weight of M2 minus the tension. But we just said from Newton's second law, this is M2A, which is equal to M2G minus T. Therefore, T, if we make it the subject here, T is going to be equal to M2G minus M2A. Now, this is also the expression for tension. So this is equation 2. Now, this is tension. Therefore, equating, we can say equation 1 is equal to 2. So what does it tell me if equation 1 is equal to 2? It tells me that M1A plus, let us simplify. For example, here we could as well say that T is equal to M into A plus G. This is what we should call equation 1. And then here we say this T is M2 into G minus A. So equation 1 is equal to 2. So what is equation 1? Equation 1 is M1 into A plus G. It should be equal to M2 into G minus A. Now let us open the bracket. This is M1A plus M1G equaling to M2G minus M2A. Now, what do we do? Let us collect the A's on one side and the G's on one side. So when this one comes this side, this becomes M1A plus M2A, which is equal to M2G minus M1G. Now, A is common. We pull A outside. This is M1 plus M2 is equal to, this is equal to M2 minus M1 into G. So if we make A the subject of this formula, we are going to get M2 minus M1 out of M1 plus M2, and this one gives us the acceleration of this body if it is M2 that was pulling. So if at all we have a calculation that needs us to find the acceleration, the first step we do is first considering the motion of each particle independently and come up with the equations. When you solve the equations, you will come up with, you reduce on the number of unknowns, and then you can substitute in that expression and you get what you need. So this is the acceleration.